Welcome! This is Dr. Plague, and today we're going to show you how easy it can be to perform linear interpolation and explain what it is. This you are not going to want to miss, so stick around! Okay, let's talk about linear interpolation and how to calculate it.
What is interpolation?
You can think of interpolation as a method of estimating something. Basically, it uses known data to estimate unknown data.
What does linear mean?
The use of the word linear in this context means basically a straight line. You'll see what I mean in some following examples. First of all, let's take a simple example. Suppose you are filling a bathtub with water, and at 1 o'clock you notice that the water in the bathtub is 2 inches deep. Now, let's say you leave the bathtub and don't come back until an hour later, 2 o'clock. At 2 o'clock, the bathtub is filled with 10 inches of water.
But if you left for an hour, wouldn't the bathtub be overflowing?
Just pretend the water pressure is low. So, back to our example. In 1 hour, the water in the bathtub rose 10 minus 2, which is 8 inches. Now, based off of that, and using your intuition, how deep do you think the water is at 1:30, halfway between 1 and 2 o'clock? You might guess it is halfway between 2 and 10 inches, or 6 inches deep. If that is what you thought, then you have just linearly interpolated the result. Now, let's graph this out and see if we can make some sense out of it. We're going to use 2 axes. We will put time on the x-axis, otherwise known as the domain. We will add 1 o'clock and 2 o'clock on the axes. By the way, since we are putting time on the domain axis, we can say we are in the time domain. You may hear this term in other videos. Now, the second axis will be the y-axis, otherwise known as the range. So, we have the domain and the range. This axis will represent the depth of the water in the tub, in inches of course. We will label some values from 0 to 10 inches on this axis. Now, let's add a couple data points to this graph. At 1 o'clock, we have 2 inches, and at 2 o'clock, we have 10 inches. Now, since we are using linear interpolation, let's connect those 2 points with a straight line. Remember, we said linear meant a straight line. Now, let's go to 1:30, or half between 1 and 2, and draw a dashed line up to the straight line and then over to the y-axis and see how deep the water is. No surprise, we're at 6 inches. Let's try 1/4 to 2 and see how deep the water is. It is 8 inches. So, this process is called linear interpolation. Now, let's see if we can come up with a formula for it. Let's call our first data point x0, y0, and our second data point x1, y1. Now, let's call the point that we are trying to estimate just plain x, y. X will be the time we are trying to estimate the depth for, so the only unknown here will be y, the depth we are looking for in inches. We know that our first data point starts out at 2 inches deep, which is y0, and we will add some amount to it to get our estimate. The amount we want to add to y0 will be some fraction of the difference between the two depths. In our example, this difference is 10 minus 2, which is 8 inches, and we'll fill this in later. The fraction will be the amount of time from the first point divided by the difference of the time between the two known points. The amount of time from the first point is simply x minus x0, and the difference between the two known points is x1 minus x0. So our fraction is x minus x0 divided by x1 minus x0. And the final formula is this. And you could rearrange this in different ways if desired. Let's try it out and see if we can get the same results. First, let's try 1:30, which is half past 1, or 1.5. So let's fill in the values and calculate the result. We have two known data points. At 1 o'clock, the depth is 2 inches, so x0, y0 is 1, 2. And at 2 o'clock, the depth is 10 inches, so x1, y1 is 2, 10. The time we want to estimate for, x, is 1.5. 1.5 minus 1 is 0.5. 2 minus 1 is 1, and 0.5 divided by 1 is just 0.5. 10 minus 2 is 8, and 0.5 times 8 is 4. 2 plus 4 gives us 6 inches, which is what our intuition told us. Now, let's try 1/4 which is the same as 1.75 for the value of x. We still have the same values as before for x0, y0, x1, and y1. So, here is the formula with all the knowns filled in. 1.75 minus 1 is 0.75, 2 minus 1 is 1, and 0.75 divided by 1 is just 0.75. 10 minus 2 is 8, and 0.75 times 8 is 6. 2 plus 6 gives us 8. No surprise, we are left with 8 inches. Now, just for fun, let's see if we can calculate approximately when the water first started filling the tub. In this case, we know the value of y, and x is the unknown. The value of y will be 0, since the depth of the water in the tub starts out at 0 inches. The time that the tub is filled with 0 inches of water is just x. So, let's fill in the formula and try solving for x. We still have our known times of 1 and 2 o'clock, and our known depths of 2 and 10 inches. 2 minus 1 is 1, and 10 minus 2 is 8. This is the same as 2 plus 8 times x minus 1. And by multiplying 8 through, we get 2 plus 8x minus 8. 2 minus 8 is negative 6. And by adding 6 to each side, we get 8x equals 6. Divide each side by 8, and we get x equals 6/8, which is 3/4. And this means the same thing as 1/4 to 1 o'clock. So we started filling the tub sometime around 1/4 to 1. Now, let's try this formula with the example of the hamster bin cage from a past video. Be sure to watch my video on building a hamster bin cage if you haven't already done so. In this example, the x-axis will represent the depth of the bedding in the bin in inches, and the y-axis will represent the cross-sectional area of the bin in square inches. We know how many square inches are at the bottom of the cage, which will give us our first data point. With 0 inches of bedding, the cross-sectional area is 578 square inches. So, x0, y0 will be 0, 578. And we know how many square inches are at the top of the cage, which will give us our second data point. The bin is about 17.5 inches tall, so with 17.5 inches of bedding, the cross-sectional area is 703 square inches. So x1, y1 will be 17.5, 703. Now, we want to estimate how many square inches there are at any point in between those two depths of bedding. So, let's start with the formula that we came up with. And let's fill in the known data points. And let's simplify this. 703 minus 578 is 125. And we're left with y equals 578 plus 125x divided by 17.5. Now, let's say we want to know the approximate cross-sectional area when there is 6 inches of bedding. 6 times 125 is 750. Divide that by 17.5 and add 578, and we get approximately 621 square inches. Now, using this idea, we can approximate the cross-sectional area for any depth of bedding.
I think I understand this. Thanks. Now I can make all kinds of calculations for the bin gauge.
Fantastic! So, that concludes my explanation of linear interpolation. Now, just so you know, there are other types of interpolation besides linear interpolation, but that would be a subject for another video. If you like this video, be sure to peck at that like button, and don't forget to subscribe and peck at that notification bell to be notified of all my new videos as they become available. Thank you, and we'll see you next time right here on Dr. Plague. Uh-oh.